In this last video on vectors, we're going to look at some real-world applications of vectors, so specifically how to solve word problems. Most vector word problems can be broken down into one of two different types of questions. The first one usually gives you some velocities of objects, so usually it's something like a plane flying in a direction, in which case the velocities they give you will describe the vectors, and if they ask you for the magnitude, you're finding the total speed or sometimes the ground speed of the object. The second most common situation for a vector problem deals with forces being applied to an object. So these are typically different people pushing on objects from different directions or pulling on different objects. Or it could also be something like an object having wind push on it from one side, but then also have gravity pulling down on it in another direction. And forces usually combine to give you a magnitude that's described in terms of pounds of strength being applied in one direction or another. For the velocity questions, sometimes the angle you are given will be described as a bearing. So it's important to remember that bearings describe the clockwise rotation from the positive y-axis. For example, a bearing of 10 degrees would represent an angle that is going up and to the right with a 10-degree gap in this piece right here, because this is the clockwise rotation from the positive y-axis. Now, very important comment about these is that angles given to you as bearings do need to be converted into the other form, the direction angle form, for you to take sine of the angle or cosine of the angle, because sine and cosine don't measure the angle from the positive y-axis, they measure it from the positive x-axis. So it's going to think you're typing in a different number for the sine and cosine values. So direction angles are what you are usually given when it's something like a football being thrown or a basketball shot or even just an object being launched in the air. So when it doesn't have to do with like a navigation system or a plane flying north, east, south, or west, then usually these are direction angles that they've given you. But as long as you don't see the word bearing in the problem, you can assume it's a direction angle. So these work the same way that the unit circle does. If you have your x and your y-axis, and then somebody gives you something like 10 degrees, then you're starting from the positive x-axis, which is on the right-hand side, and you're measuring a 10-degree angle for that diagonal line. So in this case, the 10 is over here. Direction angles are what you want to plug in for calculating something like sine of 20 or cosine of 30. If you are given the bearing and you need to convert it to the direction angle for computations, then you can do it graphically and then just try to figure out what the angle would be by thinking about what is on the other side of the diagonal line. But there's also an easy algebraic approach to this. You can just take the angle you have and subtract it from 90. So for example, if you're given a bearing of 30, then 90 minus 30 is 60. So that would be the angle in direction angle notation. The exact same system works both ways. That's why I say the conversion either way is to take the angle you have and subtract it from 90. So if you have a directional angle of 100, then you can do 90 minus 100, which is negative 10. And I do have the comment here that I recommend you take your negative answers and find the coterminal ones. So remember, if you add or subtract 360, it's another angle that has the same position. So if you add 360, then that just gives you the exact same angle, but now it'll be between 0 and 360. It won't be a negative number anymore. So I do recommend that whenever you do the 90 minus an angle, if you end up with a negative number. So here we have an easier example where there's only one speed or force being described. So in this case, we're only going to have one component form, one vector to work with. Now it is given in the terminology using bearing. So do please remember that the bearing is saying that starting from north, it is rotating 170 degrees around clockwise. So it should be landing almost straight down. They're saying that this angle of rotation is 170, which would mean that between the negative side of the y-axis and this diagonal line is 10, because it has to be a perfect 180 all the way around. Now, the important thing to note about bearing angles is that you do have to convert them before you plug anything into your calculator. So we need to think of this in terms of the math angle, starting from the positive x-axis and rotating counterclockwise around. Now you could use the diagram that you've drawn here, because this would be 90, 180, 270, and then we said this little piece would be 10. So you could do that to determine that the angle is 280 degrees, or you can do this algebraically as I showed in the notes. To do this algebraically, we just need to evaluate 90 minus the bearing we were given, and then in this case that number equals negative 80, And negative 80 is fine because remember, negative angles measure the clockwise rotation on the unit circle. But I was recommending that you go ahead and add 360 to negative answers whenever this happens. So since I got a negative answer, let's find the coterminal angle instead and think of this as 280 degrees. So that would be the positive rotation counterclockwise starting from the positive x-axis. So the counterclockwise rotation is 280 degrees. So now that we've rewritten the angle as 280, we can use our formula for finding the component form, magnitude cosine and magnitude sine. So here's the formula I was referring to that was covered in an earlier video. Since the magnitude of this plane was 460 miles an hour, we just did the magnitude times cosine of the angle and magnitude times sine of the angle. And this gave me the values 79.88 and negative 453.01. Again, it's nice to have this diagram drawn because my vector is saying that the plane is going to the right because it's a positive x value, and then it's going down because it's a negative y value. And that does agree with the vector I drew here. It does appear to be going into that fourth quadrant by going right and down for the two individual components. Now, many questions will also have a second velocity or a second force described, and that's usually for the wind, to say something like the wind is coming in at this speed at this angle. That's fine. That's just a second vector you evaluate the same way I've done here. And then once you have your two different vectors for the plane and the wind, you add those together. And that'll give you one new vector that combines all the speeds or all the forces into one. Usually when they do that, when they give you multiple forces, they will also ask you to go back and evaluate the magnitude and then the angle of the vector. So that's where you use the formulas for square root of the x component and the y component squared, and for doing tangent inverse of y over x. So most of the problems resolve around you finding the x and the y components, and then usually you also have to find the magnitude and the direction angle. It wasn't necessary on this one because there was only one vector, so my magnitude and direction angle were given in the original problem. So here we'll take a look at a problem that does have multiple forces being combined. Now this one does not mention bearing. This does not have anything to do with like a plane flying in a direction or a boat sailing over water. So I'm not going to have to do that bearing conversion. If bearing is not mentioned in the problem, then do not do that 90 minus the angle process. So in this case, I have a magnitude and an angle, and then I have a second magnitude and angle for a different force. So I'm going to evaluate the component form of each of these separately. So here is the setup for the component form of your two forces. I will mention that one of the angles was given as negative 20 degrees. I don't usually like working with negative angles. Personally, I would probably add 360 to that and evaluate it as 340 degrees instead, but it will work either way. So I figured I'd leave it just so that you could see that the negative angle isn't necessarily incorrect. I just usually find it easier to visualize the problems with the angle between 0 and 360 instead. So we have two different forces. I didn't actually evaluate the decimal values on these yet, but I am going to do that now because what I want to make sure to do is not round any of my answers. I want to add these two forces together to see what the combined effect is when both of them work at the same time. So the way I type this into the calculator is I enter this first x component, so 100 and cosine of 50. Then I'm going to close the parentheses, and instead of hitting enter, I'm actually going to type in this second x component from the other vector. So I'm going to add 80 cosine of negative 20. And then the answer I got from doing this was 139.45. So that's the x component of both vectors working together. Now I'm going to do the same thing with the y values. So I'm going to enter 100 sine of 50, close the parentheses, and then hit plus 80 sine of negative 20 degrees. So when you hit enter from doing that part, you should get 49.24. So I could have found the individual decimal values for the first vectors, but I didn't want to accidentally round my numbers off too much. I wanted to type in this whole thing to make sure that my answer wasn't getting inaccurate by rounding over and over and over again. So this is my combined component form for the two different forces working together. Sometimes they will ask you for that. Sometimes they'll just go straight into saying find the magnitude and the direction of the resultant force. Well, now that I have one vector to describe these things, I can use the formula for square root of x squared plus y squared. So here I've shown that I was taking the square root of the x component squared and the y component squared. Now I didn't write out the whole decimal for the 139.45, I rounded it off to 2 decimal places, but when I type this into my calculator, I actually make sure that I enter the entire long number, which was 139.4541706. It's very good to have a calculator that lets you go back and copy and paste one of the earlier entries, and that's what I was doing rather than hitting all of the numbers over and over and over again in the calculator. So try to be as precise as possible. Only do your rounding when you get to the final answer. This question was asking for the magnitude, so at this point it would be acceptable to round the answer to 2 decimal places. But don't round the numbers too early, because then your answer ends up being wrong if you use the rounded off numbers for the rest of the computations. So that's one important comment about this section. Another important thing that I do want to emphasize is that I see a lot of people forget the difference between -2 squared and -2 squared. These two things are not equal. Now, on my problem, they were both positive numbers, so it didn't matter. But if this had been a -49.24, then you would want to make sure that you use parentheses and put the negative inside of that, and then when you close the parentheses, make sure the exponent's on the outside, because -2 squared is not equal to, in parentheses, -2 squared. So that does mess up a lot of people's answers if they're not careful about the parentheses usage. Well, now that I've found the magnitude, we're also asked to find the direction of the force. So now we're going to do the tangent inverse formula. So for evaluating tangent inverse, again, even though I only wrote 49.24, please make sure you re-enter the entire number, the very long 9 or 10 digit number that you see in your calculator, to make sure that your answer is as precise as possible. Same thing for the 139.45. But then I did round for my final answer. So this came out to 19.45 only because I was using very exact numbers for my x and y components. It's also important to remind you guys when you're doing the tangent inverse, when you're trying to find those angles, there are 2 important tricks. One of the tricks is that you have to remember to check what quadrant your vector was in. This quadrant had a positive x value and a positive y value, so the vector was going up and to the right into the first quadrant. So I do not need to add anything to this number. If it had been going into the second or third quadrant from the vector, not based on the angle, but if the vector was going left and up or left and down, then I would need to add 180 to this answer. And if it was going right and down, so a positive and a negative, then I would add 360 just to find the coterminal version. The other trick that can happen on this is if the question was a bearing problem, if it was something about the bearing of the plane, then after you found this angle, you would have to remember that what we have is the direction angle right now. So to change it back to a bearing, you would do the process of 90 minus the angle you just found, and then if necessary, if it's a negative number, I would recommend finding the coterminal one instead. But this one is done here because the problem never mentioned a bearing. This was not a navigation problem. Now I know word problems are always difficult, and I did want to give you guys some closing comments and hints just to help you for what I hope will assist you in the assignments. Basically, you can boil down all vector problems to just saying find the component form of the vectors. If there are multiple, add them together. And then once you have that one single vector, you're probably being asked to find the magnitude and the direction angle of it. They may use different terms like ground speed, but that's just another way of saying find the magnitude of the vector. I do also recommend drawing a sketch off to the side so that you can kind of see if your numbers are going in the direction you expect. If it should be going up and to the right, then make sure your x and y components are both positive. Also, don't forget, never plug bearings into your calculator. If they say bearing of 30 degrees, then make sure you convert that bearing into the direction angle before you start plugging numbers into your calculator. And then at the very end, when you get your angle for an answer, you'll probably have to convert it back by doing the exact same process, 90 minus the angle you got for your answer. Now there are some problems that will use a different method for describing the angles, so I'm going to show you how this works. My recommendation when you see something like north 25 west is to draw a quick x and y axis. The first thing they're giving you north is saying start on the north side of your compass. And then they're telling you how much to rotate towards either east or west. So in this case, we want to go towards west, so to the left. And the amount we should be going is 25 degrees. So that's the angle in between north and my diagonal line. Well, for the direction angle, we need to measure this entire angle of rotation. So my answer would be the 90 for the first quadrant and the extra 25 in the second quadrant before I hit the diagonal line. So 90 plus 25 would be 115. Very similar, here's a second quick example. South 42 east means start at south, so on the bottom, and then they're telling me to rotate towards east, which is on the right hand side. So start from south and go in this direction, and the amount we should be going is 42 degrees. So that's the angle in between straight south and my diagonal line. Don't forget that the angles in a quadrant should add up to 90, so you could always do 90 minus the number you see to get your answer. So now that I know that this is 48, you could think of this as negative 48 degrees, or you could still measure the rotation going all the way around the opposite direction. So that would be 90 degrees, 180 degrees, 270 degrees, and then we're adding an extra 42 before we hit the diagonal line. So 270 plus 42 is 312 degrees. This angle is coterminal with negative 48. That's why either of these is allowed. I usually like the positive one between 0 and 360. So that's it for the notes. I hope that'll be helpful on working with word problems.